Okay, good morning, everybody, and thank you for joining us today. Today we have a very interesting group of speakers, and we're very excited to have them join us. I am going to, just to give you a quick overview of what we are doing in this session today, I'm going to introduce our speakers. We have 3 speakers in addition to myself. I'll give a quick introduction to a program that we've been developing with the community, and that we would love to you to hear about it. But before I continue, let me just give you a quick overview and an introduction to myself. So my name is Ana Pinheiro-Privets. I am a senior program manager at Amazon. I'm actually with the sustainability team, but we work very closely with our collaborators on the AWS Open Data team on this initiative that we launched last December called the Amazon Sustainability Data Initiative. So I'm leading that initiative as well. And it's part of this umbrella and this bigger effort that we are doing to promote more sustainability work and innovation in the world that we are very honored to have 3 great speakers with us today. I'm going to ask them to come on board and into the stage in a second. But before that, let me just give you a little bit of context into the conversation today. Okay, so this is just the agenda we'll have, as I mentioned before. But to set the tone for this broader conversation, I would like to talk about global sustainable development and why is it so important, the work that these groups that are here with us today are doing and many other ones around the world. So as we think of global sustainable development, we really have to work on this delicate and complex relationship between ensuring or promoting economic development and prosperity around the world, at the same time ensuring that we are protecting the environment and we are basically doing some social fairness around those activities as well. And more importantly than ever, to enable sustainable development, we need to have access to meaningful and timely information or insights or actionable knowledge or whatever is your preferred word. But the reality is that this is not always what we are observing, right? So we are in a period of our history where we have more information and data than ever. We have, new constellations of satellites, and models are producing more high-resolution data than ever. And we have Internet of Things, and all this technology is producing so much data, but that's not always necessarily translating into more meaningful insights for people that are trying to make decisions in terms of sustainability practices. So what we believe is that perhaps part of the challenge that we are observing is the fact that although there's all those data sets out there, discovering the data, accessing the data, and using the data is not always as easy as it should be. And I love this quote here from DJ Patil and Hillary Mason, because he actually quantifies what we all have heard for so many years. And I was trained as a scientist, and I experienced this myself. We spend a lot of time, and most of the time, actually finding information, the data, and trying to put it in a format and in a way that enables to actually generate insight and extract knowledge from it. So our goal at Amazon and AWS specifically has been working very strongly and in a committed way to remove that undifferentiated heavy lifting. So we believe at Amazon that we believe strongly that there's a role we can play in trying to address some of these challenges. And in response to that, last December, we launched the Amazon Sustainability Data Initiative, which really aims to reduce all the costs, or most of the costs, the time, and the technical barriers that are preventing us from innovating for sustainability and problem solving. What is specifically the Amazon Sustainability Data Initiative? So we are trying to build this ecosystem for change. We truly believe that leveraging the scalable infrastructure of the cloud and all the technology associated with it can help us open the space of innovation and take us to another level. And we work on 3 primary areas. One is the data, and we're very focusing on removing the burden of data acquisition, and I'll explain a little bit more in a second. The other one is analytics. How do we democratize access to all these tools and technology that in the past have been traditionally available primarily to the researchers and the organizations that had the big data centers and the high performance computer access. So how do we democratize access so that more people have the ability to look at these data resources and extract knowledge from it? And then the third one, which is related to the other two but is really critical, is the reality is that the sustainability community traditionally has been working, as many other communities, outside the cloud, and there's still some barriers in the sense of how do we make it more accessible and easy for all of us to move forward in this space? So a big goal of the Amazon Sustainability Data Initiative is to try to remove some of those barriers, those technical barriers, by promoting knowledge exchange and encouraging the community to share what they've learned and the lessons they've learned and what's working and not working. So in terms of the data, one of the key activities that we do is work very closely with AWS customers and the community in general and say, okay, what are those foundational data sets that if we put in the cloud and make available to everybody might unlock a lot of innovation or problem solving? And we do that very intentionally. And so our intention here is not to bring all of the data to the cloud, because we feel that kind of defeats a bit the purpose. I think the main effort here is really to understand what are the foundational data sets. How do we curate a catalog that has those data sets that are critical for this conversation? So in the initial phase of this program, we've been working very closely with data providers around the world and trying to bring those authoritative data sets that can help with this conversation. And these are just some of the examples of the type of data that we currently have in our system. Anything from weather observations to air quality, and a lot of climate-related data as well. And we continue to grow and build this catalog in response to the needs of the community. So we want to hear from you if there are specific needs that we are not addressing so far. Okay, the other one, as I mentioned, a little bit more about the democratization and access to analytics. What we do in practice is that we enable anybody that has an idea that would like to experiment in the cloud. So if you have an idea in the space of sustainability and you would like to try and either use the data that we already have in the system or bring your own data and experiment and develop some kind of a workflow or an algorithm in the cloud or an application, we are very encouraged to support you and provide cloud credits. So please reach out if you have any interest. And the real benefit here is that now the data is co-located with all this large amount of capabilities and tools that we have in the cloud. We have over 165, I believe last time I checked, I'm sure outdated right now, specific services that AWS is providing, and those would be available to whoever wants to do this experimentation. Okay, and the last one, just a little bit more detail. As I was mentioning, it's really critical that we move forward together and that we understand how we can learn from each other about the things that are working or not. This is still a fairly new space for the sustainability community. So we've been very actively trying to understand how do we build tutorials that help us how to go from point A to point B and basically tell the stories of the struggles that people are going through, how do they overcome them, and how can we all learn more from each other. Okay, so that's it from my side. I just want to make you aware of this initiative and let you know that we are very eager to work with groups like the ones we have here today and all of you to understand how we can push this space forward. So reach out if you have any additional questions or want to get engaged. And before, I think now we will move into the very interesting part, which is to have our speakers. So I'm going to ask our speakers to come on stage, and I will invite Stephen Ramage to come on stage. Stephen is with Geo, and I do have his bio, but my computer just locked, so give me just a second. And Anne Miklaresi, please to join us, and Aditya Agarwal. Okay, so just a few words about Stephen. So Stephen heads the external relations for the Group on Earth Observations, and I don't know how much you know about that group, but it's an intergovernmental organization, and he will tell us more about. But so he is the head of external relations for this group. He spent most of his career in the private sector working on geospatial software, tools, and services before moving into public policy, notably around open data and open standards. He also would like you to know that he just recently launched a GoFundMe campaign to Kibera Kitchen in Nairobi, and he would love to tell you more about it. So if you want to learn more about that, please reach out and find Steve after the session. Then we have Anne Migleresi. Anne is the founder and CEO of Radiant Earth Foundation, which is a nonprofit organization that focuses on applying machine learning and data science to Earth observations to meet the world's most critical challenges. Prior to launching Radiant Earth Foundation, Mrs. Migleresi served as the president and CEO of Fugro Earth Data. Did I pronounce that well? As president and CEO of Planet IQ and a principal director at Booz Allen Hamilton. In addition, she has worked for the National Oceanic and Atmospheric Administration, where she directed remote sensing and GIS programs for over a decade. Aditya Agrawal is the founder of D4D Insights. Do you say it differently? Is that D4D Insights? All right, a mission-driven company focused on catalyzing data innovation and solutions for sustainable development. His careers focus on how data sharing, open data, and geospatial technologies can enable better collaboration, coordination, and access to information for better decision-making and action. Currently, Aditya is acting as the senior advisor for the Digital Earth Africa, which he will be talking to us about today, a transformational program being established in Africa to provide operational data services, delivering analysis-ready satellite data for the whole continent. So very excited to have you three here. And I think we will jump straight into Stephen's presentation, right? Does that work? Okay. So I'll actually get out of the way.
Thank you.
Would you like, do you have a microphone?
I'm mic'd up. Good morning. Oh man, that's rubbish. Good morning. That's better. Thank you for coming so early and getting out your bed. If you can't understand me, I'm Scottish, so one of these two can translate for you. All right, so my slides are... Okay, so I'm going to talk about work that we're doing in a number of countries around the world to look at really the value and impact of Earth observations relating to sustainable development. Anna talked about the launch of ASDI in late 2018, and about 6 months previous to that, we approached Amazon and said, we have countries that are working with kind of cloud credits of $5,000, $10,000, and it's kind of rate limiting. So we'd like to help these countries to get more access to cloud services. We'd like them to understand the value and how to use cloud. And so we asked Amazon to give us about $1 million. Well, we said we wanted about 25 countries to get something between $50,000 and $100,000. So went through the process, and yesterday you may have seen the announcement that we got $1.5 million to distribute across a number of countries. So that's fantastic, and it's under the banner of the work in ASDI. And the whole purpose of doing this is that we offer all the countries that work in GEO, in the Group on Earth Observations, an opportunity to develop. We work in a number of different areas that we call societal benefit areas. So these are agriculture, biodiversity, climate, disasters, energy, fresh water, forestry, oceans. So many of the areas where you would imagine or you know that Earth observations play a major role in terms of providing insights and data and information. So we launched a call that went out to everyone. And what I want to kind of like make clear is that when we talk about Earth observations, we're talking about anything in, on, or around the Earth. So quite often people think that we're only talking about satellite imagery, but actually from our perspective, it's anything. So here it says anything where it's atmospheric, oceanic, or terrestrial. So we're looking, we've been working on things like groundwater, soil moisture, ocean salinity. So it's many other areas that are complementary and that are used for the calibration and validation of the satellite imagery. So that's why we're the group on Earth observations, because it's anything related to Earth observations. So GEO's been around for since about 2005. So we had the first decade, 2005 to 2015, and we're now in the second decade of the program, which runs to 2025. And originally we were trying to build this global Earth observation system of systems, and that's where we've kind of focused. Now today we're moving much more. We focused the first decade on open data, and now we're looking much more at open science. So we're looking a lot more at reproducibility of results. We're looking at things like the FAIR principles, so where data is findable, accessible, interoperable, and reusable. So these are the things that we're starting to do. And the collaboration with AWS is a big part of that, because it's about enabling countries to do more than what they've been able to do before with Earth observations. So we work across the globe. We work in 7 continents. I can't read that, by the way.
I think, yeah, you shouldn't go by that.
And we work across, I mentioned the societal benefit areas, and we've been around for 12 years. The key to what we do is that we have 70 work program activities, and these work program activities tend to have a life of their own. So, for example, some of the key work program activities, we have GeoGLAM, which is Global Agricultural Monitoring, which is about 100 different organizations working together. We have GeoBond for biodiversity observations. We have GFOI for the Global Forest Observation Initiative. We have Mercury monitoring. So we have many, many different activities which have a kind of a flow-through of, over the years, billions of dollars and thousands of different practitioners who are working on them. So we created, over the last 5 years, we created something called the GEOS platform. And that was the first time that we approached Amazon and we got cloud credits for the GEOS platform. So we started that about two years ago. And the GEOS platform is essentially a way for people to access the metadata for about 165 catalogs. So that represents 7,000 data providers and 400 million open data Earth observation resources. So as I was saying, it's not just the satellite imagery, it's other types of Earth observations. So then, because we already had the relationship with Amazon, then we got the Cloud Credits program. So we created this so that, according to UNDP, the United Nations Development Program, any countries that were classed as developing countries could apply for this. So we ran the program towards the end of last year, between December and April this year, and we made it for, essentially for non-commercial projects. So it was where countries were working in topics and in thematic areas that relate to the work of GEO. So with 70 work program activities, it's a huge, huge amount of activity. So to give focus to that, we have 3 engagement priorities, and those are around policy drivers. So the first one is the Sendai Framework for Disaster Risk Reduction, which is led by UNDRR, the Office for Disaster Risk Reduction. Then the second one's the Paris Agreement, working with UNFCCC, the Framework Convention on Climate. And then the third one is the Sustainable Development Goals. So working with a few organizations like United Nations Statistics Division, as well as UNGGIM, the Global Geospatial Information Management Committee of Experts. So people had to submit into that. At the same time, and this touches a little bit on what Aditya is going to say, at the same time, there were already some things going on with a number of GEO members and partners. So through NASA and through the Global Partnership for Sustainable Development Data, some work had started in Africa in 5 countries. So people who are applying are also already doing work through other programs using AWS. So some of them wanted to just elevate their credits and their knowledge and the capabilities in AWS as well. In terms of the support, we're working with the AWS team, but we're also working with a number of different other organizations. So there is the Committee on Earth Observation Satellites, which is 55 space agencies who are providing the data and working. So we're working through CEOS. We're also working with a number of different organizations, for example, Synergize in Europe, who do the Sentinel Hub. They've also provided some supplementary credits to support that as well. So we have a community of people who are working together to help the countries, whether that's in the thematic areas or whether that's on the stack and the infrastructure itself. So one of the things that has come up as an important element of this is the Open Data Cube. And again, I'm presuming Aditya's going to talk more to this, but I just wanted to flag that these things are complementary. We're bringing together a number of different initiatives that are happening around the world. And I'll touch on that a little bit later towards the end of this session. So if you want to learn more about what we're doing, there are over, we had something like 30 different applications, 30 different countries who came through, and all of these are developing countries. And so it covers a cross-section of areas from, related to the policy drivers, but it's got things like land use, land change, forestry cover, tsunami warning systems, and many other things that I guess will be relevant to people in this room. So just to close, we have, every year, we bring together the 100 or so countries, and this year is a ministerial, so we'll have ministers there talking about the impact and the value of Earth observations. So the theme of the event is return on investment for Earth observations. So we'll actually be getting ministers to come in to make commitments and to talk about what their countries are doing on Earth observations. So typically in a country that we work with, there's anywhere between 5 or 20 different agencies that work with us. So with over 100 countries, that represents somewhere around 1,000 national government agencies in the GEO network that we're working with. So that hopefully gives you an idea of what we're doing. And we're really pleased to be working with ASDI and to be here to share some of the information with you. Thank you.
Great. Thank you so much, Stephen. I will now ask Aditya to please tell us your story.
Good morning, everyone. Thanks for coming to this session. I'm going to talk about Digital Earth Africa and some of the points that Stephen was raising around open data cubes. And so an open data cube, I guess in its simplest form, is basically being able to put Earth observation data into an analysis-ready format, and then it basically puts it into a time series. So it basically addresses the slide that Anna had put up originally. So about 80% of the time that's spent on processing Earth observations is spent on all the pre-processing work that's needed before you actually get to any analysis. And so by putting it into a data cube, you're taking those Earth observations data and really creating decision-ready products from that so that you're able to enable further down the line types of decisions and actions around that data. And much of this technology was developed by Geoscience Australia. Once they identified how useful this technology could be, they made it open source, and other organizations like the Committee on Earth Observation Satellites picked it up and really tried to scale how open data cubes could be applied across different countries. One of the benefits of not just an open data cube, but open data in general is that for Australia, being able to apply Landsat data for the entire continent would have required 300,000 scenes to do so. Before Landsat data became openly available, it was about $1,000 a scene, which would then have resulted in it costing about $300 million for Australia to do that, which would not have been possible. So that just kind of speaks to the power of open data and all the other kind of down the line uses that you get from information once it's accessible. So before the work that I'm doing now, I used to be at the Global Partnership for Sustainable Development Data, where I was leading a lot of the country level engagement in relation to how countries were addressing all of their data gaps in relation to national development priorities, sustainable development goals in Africa, Agenda 2063, and so on. But essentially what the intent was is that there's a number of data sources that are available that countries can really leverage in order to be able to address a number of the needs at the country level and be able to do it in a multi-stakeholder approach where you have governments, private sector, and civil society working together. And so what came out of that was a lot of demand in the sense that through these national workshops that we were holding, the idea was to be able to identify what those particular gaps were through this multi-stakeholder process and really understand where the demand was that we could then work with partners to define different types of solutions. And so through that process, with a number of partners that are listed on this slide, including Amazon Web Services, who was able to give us a grant for launching the Africa Regional Data Cube, it basically addressed a gap across 5 countries in Africa, which was that there was limited capacity on how to use Earth observation data, and there was limited capacity on how to access that data as well. So for 5 countries, Senegal, Tanzania, Kenya, Ghana, and Sierra Leone, all had similar demand and similar use cases, things like agriculture, food security, deforestation, coastal resilience, illegal mining, all of which are types of problems that Earth observation data can easily address. So this infrastructure was established for those 5 countries as a prototype to see how a data cube could support some of the demand within those countries. At the same time, as Stephen had indicated, there was a number of conversations that were already happening in terms of how to kind of scale the approach, not to do it country by country, but then region by region. And so starting about June of last year, the Australian government was able to come up with some money to come up with our phase 1 approach, which was essentially building out the business case for creating an operational level service for all of Africa called Digital Earth Africa. And so over the last 8 months or so, we've been working with a number of stakeholders across Africa to better understand what the landscape looks like, what are some of the user needs and requirements, what institution can the program be housed within Africa, what are the capacity building needs, how do we build political buy-in for this type of an initiative and build further awareness and so on. So we created the phase 1, we worked on the phase 1 approach last year, which concluded in about January of this year, and now we're moving into the implementation phase. I just wanted to show you a couple of examples of what's possible through a data cube, and these are all examples coming from Australia, and I hope this is gonna work. I think it takes us, okay. So you see a little black box there, that's one farm plot. And so this is basically doing an NDVI analysis across a time series where green is healthy vegetation and red is barren soil and yellow is dry. And so basically what you see when you get to about 2005 is that the farmer within that particular plot made a decision to change the type of crop that was being farmed in that field. And now you start to see this trend where the vegetation is getting much healthier. And so really the point here is that you're able to really be able to visualize when you're making particular decisions across a particular time series where all this data already exists. And you can then replicate that for every plot. Here's another example looking at water quality monitoring. So this is looking at sediment load that's going into this lake. You see that black line, that's a transect going across the lake, where blue is better quality water and red is worse. And so the city of Canberra made a decision around the year 2000 to reduce the amount of sediment load going into this lake. And now again, you're able to really visualize the effectiveness of a particular policy over a time series to ensure that that policy actually is working. A couple of examples from the Africa Regional Data Cube. One of the key issues in Ghana was around illegal mining. And so Brian Killow and his team at CEOS and NASA started working with several of the government agencies in Ghana to come up with an algorithm to be able to detect illegal mining. And so Ghana was then able to provide validation and training sites. They kind of tested this algorithm, and now they're coming out with, they're refining the algorithm, but they're coming out with some good results where these illegal mining sites might be. And this is a problem that's prevalent across many countries in Africa. So as these algorithms are getting created, then it also scales how those algorithms can be deployed in other countries. Another example from Tanzania, this is doing a water observations from space example. and this is likely to be one of our first continental-wide data products within the Digital Earth Africa program. But this is originally developed for Australia and then applied in Tanzania, and this was used as a way to kind of test how these algorithms could be applied across different regions. And so this is so working within the data cube, you're basically setting up your analysis area, you're importing the data and masking out the clouds. That's already an automated process within the platform. You're running the water observations from space analysis that then identifies where the water bodies are. And then you're basically computing how much water coverage there is at each time step. So then they basically took that process and applied it to this one particular lake. And then you're able to see what the fluctuation in total water area looks like. And what they identified was that once you're able to see what that water coverage looks like for that particular lake as it sort of increases and decreases, you're also getting an idea of what the hydrography of that lake also looks like. So you're basically being able to generate the contours for that lake. And let's see if this works. I knew one wouldn't work. If this worked, you would see that map spinning around and the water depth going up and down through each different time step. So basically what they were able to do is take those contours and create a 3D visualization around it. How am I doing on time? Okay. So now as we move forward into Digital Earth Africa, what we're going to be doing is creating an operational data cube. So it's essentially going to be creating services, information-ready products, decision-ready products, where it's automated, run for every pixel, creating continental-wide data products. It's going to be institutionalized within Africa, so we're working with the UN Economic Commission for Africa to be that institutional home, and leveraging partnerships with a number of other institutions that have similar mandates to work with countries on these types of issues. It's a fully funded program now, so we have funding for the next 3 to 4 years. It's going to be staffed up to 30 to 40 people within that time period. And it's a program that we want to be able to align to other initiatives, be interoperable. And from our perspective, this is a free and open resource, and we'd like to connect up with other systems where we're able to share data and algorithms. We're very much in kind of the early stages of Digital Earth Africa, so we're setting the foundation for it right now, establishing the governance, working towards country engagement, identifying user needs and requirements, building out the technical roadmap, creating partnerships, understanding alignment, capacity building, and so on. So we're hoping to be able to do a small launch event next month, and then be able to do another event in Nairobi in August that's aligned with the RCMRD Afro-Geo conference that's taking place there. So again, I want to shout out to AWS. Thank you for the grant that really made the Africa Regional Data Cube possible. As we look towards Digital Earth Africa, this is going to be cloud-based also, so we're looking to really work with AWS on a partnership towards that. One of the things that's really going to be able to accelerate that is that the USGS is already working on level 2 analytically ready data that they're going to put up on AWS that will make this whole process much easier. And by having a data center that's going to be in South Africa, that's also going to help with some of the perspective in terms of data being shared in the cloud. I know I'm probably out of time, so I just want to just say really quickly that kind of our 3-year vision is really we're working on setting the foundation this year, and as the infrastructure gets developed, we'll be working towards capacity building and uptake, which is a huge part of our program. And then we eventually want to be able to get to an ecosystem approach where this is an open data infrastructure and users across sectors, government, private sector, civil society, are innovating and building applications on top of the infrastructure. Thank you.
Thank you, Aditya. So now we're going to hear from Anne, and she's going to tell us what the Radiant Earth Foundation is doing to use some of the open data and cloud technology to push us to the next level of understanding and generation of insights.
Great. Thank you, Anna. And I am going to lean on this chair because I, A, have a fear of edges, and B, have stepped off a stage before. And there's not a lot of room to migrate up here. So anyway, thanks for the invitation to participate this morning. I appreciate it, and to get to share with many of you some of the recent initiatives of the Radiant Earth Foundation. So the world is changing very, very quickly. I have been lucky enough to be in this field, employed in this field for 35 years. And the wealth of data that is now available is mind-boggling. I remember when the first Landsat flew, and what a great opportunity that was. Now you look at the number of satellites that are being launched on a monthly basis, and I actually quit updating this chart last year. It's greater than 600 on orbit now. That's a mixture of college-based CubeSats, commercial satellites, government satellites. And I also think the community writ large across the globe has done a very good job about talking about open data. And data now truly is open with Landsat and the Sentinel and Copernicus program because it's accessible. It's no longer do you have to have an FTP to USGS in the EROS data center. It is truly accessible, and that would not have been possible without the cloud and the cloud infrastructure. I know when I had my first management job, managing a large remote sensing project in 1988, I was mapping at a very high resolution a 3,120 square mile watershed. And we bought our first, we had an ERDAS system and an Esri GIS system all on a workstation, and we bought our first gigabyte. Anybody want to guess how much that gigabyte cost? $1 million. No, but $28,752 plus tax for 1 gigabyte. And I was really depressed after about 6 weeks when the system administrator came back and said, we need more. I was like, well, wait a minute. The long and the short of it is, I have never been so optimistic about the possibilities of putting Earth observation data to work, whether it's from a drone, whether it's from a satellite, whether it's from an aircraft, whether it's electro-optical, whether it's radar, whether it's LiDAR. We're awash in data, and now we have the technologies to scale. We have the cloud computing. We are now, on a regular basis, applying machine learning to the data, blockchain, the Internet of Things. All of these technologies are coming together very rapidly, which I think, and many others, more importantly, think will create a digital twin of the Earth in the next decade. So from that, we're seeing rapid innovation, which I think is all good. With machine learning, though, I think there's a new promise and some new challenges as well. When you look at the traditional analytical model, where we used to have data and statistical theory and fed it with domain knowledge to create this handcrafted model and got some data and hopefully some predictions out the other end. Now we're taking that data, of which there is a wealth of, and measured outcomes, which there is not, and learning algorithms, added to that the domain knowledge, and getting machine-driven models that hopefully are producing new data and much better predictions. I think that this is coming at a time that is ideal, particularly in the global development community, where we have so many intransigent problems. The ability to use machine learning to quickly recognize patterns and generate insights from these huge amounts of data, to improve and automate predictive forecasting for crop yields, for disease, for illegal mining, illegal logging, and to optimize those processes and predictions and forecasting. But again, I'll draw your attention in that bottom quadrant to measured outcomes, and what I will say is labeled training data. So in order to run machine learning on Earth observations, we need samples of what's happening on the ground. Some are relatively easy to discern from the satellite imagery, like a forest, and some are not, a soybean field. Some require in situ data collection and field measurement, and some can be generated by the crowd and a smart analyst. In addition, the cropping patterns around the globe are very different. And what we see here in the US is that there's a tremendous amount of training data available. It may not be truly open. It's open legally, but it's not accessible. But the cropping patterns here in the US and the land cover here in the US is generally very, very different from that in the developing world. And we need training data sets that have geodiversity. We need data accessibility. We need interoperability of that training data, and it needs to be analysis-ready data, machine learning readiness. The results are not having this data is biased or incorrect results in the inability to capture a wide range of possible outcomes through space and time. I would call your attention to the bottom circle here and aggregating ground truth data. That's an initiative called ML Hub, one that we launched about a year ago, and we've recently at the foundation made a pivot to put all of our focus on this initiative, Machine Learning Hub for Earth Impact. So what we're asking the community is, and working with a broad community across the globe, is to increase the diversity of that labeled training data. To use that with transfer learning methods, to generate thematic training data sets, and to create transparency through collaborative efforts. So what do I mean specifically by that? We're establishing a community focused on advancing the application of Earth observations, data challenges in the Global South, using machine learning techniques. We have built an open source machine learning hub. It will be launched and totally public in July. There you will find training data as well as open models and standards for sharing that data. We're also crowdsourcing ground truth image labels, working with organizations across the world. In our efforts to educate and inform on this initiative, we are convening technical working groups. We held one last June to bring together 25 of the leading machine learning scientists on land cover and talk to them about the training data that's needed for the future and the schemas that will be mapped to. We will be convening another workshop in November of this year to talk about, and again, with the science community, an intersection of the satellite science community and the global development community that have a lot of practitioners in the field that are very pragmatic, that need end results, to talk about best practices in generating training data and labeled information, and we will publish that back out. We have a number of fellows now that work on these issues for us around the globe, and we'll be publishing on that on a regular occasion. So to give you a feel for a couple of data sets that we're working on in-house, so primarily what we would like to do is to share these standards, to advocate for you to share your training data, right? Because we've done a great job on satellite open data with the Copernicus program, the Sentinel suite of sensors, Landsat, and others. But now we need to do that same level of effort with the training data that will allow scientists across the globe to generate benefits and insights from that. Internally, though, we're also, where opportunities arise, building training data sets. Right now, we're building 2 data sets, the major crops of Africa, as well as a global land cover training data set. They're all hosted on AWS, as is all of our infrastructure. And it'll be available under a Creative Commons license publicly in late July and early August. So with that, I think I'm right on time. So that's it. Thank you.
Perfect. Thank you.
And I didn't fall off the stage.
So thank you to the three speakers. This has been really interesting, and it's amazing to see the kind of work that you're doing and that the cloud and open data is enabling. Unfortunately, we don't have too much time. We have a couple of minutes, so I'm going to ask you just one question to all of our, to the three panelists. So as I introduced before, the Amazon Sustainability Data Initiative is really focused on trying to remove barriers and enable groups like yours to move this space forward. And I would ask you, in an ideal world, if you can remove your biggest obstacle that is preventing you from moving faster or making a bigger impact, in the context of access or use of data and analytics, what would be the thing that would come to your mind that in the ideal world, I wish this would happen? And I know I'm putting you on the spot because we had prepared different questions, but we don't have time to go through all of those.
Well, I mean, from my perspective, technology is not the problem. It used to be getting your hands on the data, as you put up in your original slide, was 80% of your time. Technology and data acquisition is not the problem. In the developing world, what I see is the capacity development, but also the policy issues. And the policy issues we've struggled with in this country as well. So taking a very narrow view of that, from trying to create ML Hub and get that populated, getting academics and practitioners and governments from around the globe to share and register their data.
Thank you.
Yeah, I totally agree with that. So the first thing that came to my mind was politics. But really, I mean, the same thing. It's like, the technology and the technical issues are not really what the problem is. We can always apply that. The harder part is being able to work through institutional arrangements and trying to get people to work together. And so I think in the context of Digital Earth Africa and a lot of open data sharing types of programs, working on the policy element, but then also trying to find the common space that leads to how organizations are better able to coordinate and collaborate is kind of the tricky part that you have to get over.
Thank you. And maybe I'll take Stephen, if you want to say it very quickly, but we also would want to take this opportunity for Stephen to spend just 1 minute or two giving us a quick overview of this announcement that came out yesterday, but also, this is a chance for us to hear a little bit more about the countries and the projects that are going to be working.
So the URL's here. You can get it on the AWS government website as well. So they launched a blog post on it. I put some stats in this morning when I woke up at 4 a.m. with jet lag. So we had 13 applications for Sentinel-2, 8 for Landsat, 7 for Sentinel-1, 5 for MODIS, 4 for CBERS, RadarSat and GOES, and then we had 5 for the Open Data Cube, and pretty much, I'd say about 60% of them didn't know about AWS Open Data on S3. So I think we've got a bit of an education program there to inform people. The key with this is that there'll be a lot of data products that will be produced, and similar to what Anna was saying, all of the data, the software, the algorithms, the methods will be openly available, publicly available. So that's the goal, is to make sure that we have this reproducibility and we move towards sort of not just making the open data accessible, but this kind of open science approach. There's not really much else I want to say. I mean, some of the projects that have applied, I picked one of them because there's 21 from. Can you click on the link for the? There's 21 projects from 17 countries. One of them from Indonesia is also working with Chile, Ecuador, USA, Japan, and the Caribbean. So it really is a global initiative that's bringing together experts from around the world who understand the thematic area, the Earth observations, the policy area. And they're looking at taking global differential GPS. So they're looking at Beidou from China, GNSS, GLONASS, QZSS from Japan. And they're building a number of tsunami models, earthquake models. So it's really a mix of the scientific approach, the programmatic approach, and the business impact, and all of those things going into the Amazon environment. So I don't really want to say much more, but you can read all about it. It's all available on Amazon's website or on our website. But I'd encourage you to have a look at what the different countries are submitting as projects.
Great, thank you, Stephen. And we will be hearing more about what these projects are doing over the coming months and understand how to share that with the broader community. So thank you. Please help me give a big round of applause for our three speakers. And thank you all for being here today and joining us. And have a great day.